Hello everyone, this is Abaqus here from ADACS, and in this video I will introduce TFAT XFEM 2025 and we will go through one of the tutorials. So TFAT XFEM 2025 is a new tool released by ADACS that allows the user to submodel and remesh their model with the mesh refined around the crack front. It also automatically prepares the level set definitions for irregular non-planar cracks. TFAT XFEM prepares the job, the mesh, and the level set definition files needed to run your Abaqus XFEM job. As an example, we will run the CTSpecimen tutorial provided with the tool. This tutorial demonstrates the use of TFAT XFEM for preparing an Abaqus XFEM propagating crack job for a compact tension sample under monotonic tensile loading. In this tutorial, we will use a predefined crack mesh file. Okay, so we'll go ahead and start our tool. Okay, we will press Open IMP. Go to CTSpecimen tutorial folder. Select CTSpecimen job.imp. So as you can see, this is our CTSpecimen model. You'll enter HS1 as our hotspot name, import our crack mesh, CTSpecimen crack.imp, and as you can see, that's our crack mesh there. Okay, so we'll press next. So in this case, we will not be doing submodeling, so we'll just skip this step. Next. So we will keep our element size to be 3, so that's our desired element size for remeshing this model. And we would like our elements around the crack front to have a size of 0.3, so that's our crack resolution. And the size of the region around the crack front that will have this resolution, we will set it to 5, so that's set via fine region. Okay, so we can press preview and we'll wait for it to finish remeshing. Okay, so once it's finished remeshing, we can see our mesh. Okay, and we can see it's also defined the level set psi, okay, and phi. Okay, so now we press next. We select our material file, CTSpecimen material.imp. We'll enter our Abaqus command. So this is the command used to run Abaqus from the command line. I only have 4 CPUs on this computer, so I'll enter 4 as the number of CPUs. Press next. So we have an elastic material, so we will output the stress intensity factor. We'll select the number of domains as 10. Okay, and we will enter an enrichment radius to suit our model size as 1. Press next. We press prepare IMP file. Okay, so the first thing that we need to do is change the LSET name to part 1. We also need to add the reference nodes that got removed during remeshing. So the reference nodes are the 2 nodes centered at the holes of the CTSpecimen. Okay, so and we can get these from the original CTSpecimen job.imp file. Okay, so we open the original file and we copy these lines and we paste them underneath the mesh inclusion. Okay, we change the crack type to propagation. Okay, and we add additional outputs, psi LSM and phi LSM, and we also output status XFEM to be able to see the crack in Abaqus. We save and close the file. At this stage we can press start analysis. Okay, so we don't need to remesh because we already did a preview and we have a mesh, so we keep our existing files. Okay, and we will wait until the analysis is done. So here the job has been submitted to Abaqus. Okay, so this could take some time depending on your computer. Okay, so once the simulation is done, we can view our von Mises stress contour plot. Okay, for all increments we can step through the increments like this. Okay, and we can go to the last increment using this button here. Okay, and in this table we have our stress intensity factor values, all three of them, so K1, K2 and K3. Okay, and we also have the crack direction angle. Okay, so these are available for all increments. Okay, so we can change the increment here. Okay, suppose we go to increment 150 for example. Okay, so the values are tabulated like this, with the domain across the columns and the section along the crack front across the rows. Okay, we can select a particular column to plot the K value across the crack front. Okay, and we can also select a particular section via row to plot the K values for different domains. Okay, so we can see whether it's converging to a particular value or not. Okay, alright, so we can also see the results of the simulation in Abaqus. So if we open the ODB file, okay, from C program files TFAT XFEM 2025 CTSpecimen tutorial XFEM, we can double click on the ODB file to open Abaqus. And in Abaqus we can animate the simulation. Okay, and we can see how the crack propagates here. Okay, so that's the result of the XFEM simulation. So you can see the crack propagating and the stress fields changing. Okay, so that's the end of this video. If you have further questions, please visit us at adacs-eng.com. Thank you.